This video, I'm going to show you how to go from set builder notation to interval notation. Some of y'all have seen this before, and if you've taken Algebra 1 with me, we covered it in there. But if you haven't, that's okay. And if you don't remember, this is going to be a little refresher so that we can learn how to write domain and range in set builder notation and interval notation. Now you'll be able to choose, pick and choose. Most people like to choose interval notation because it's simpler, less writing, okay? So to remember how to write interval notation, I've nicely stated here when we use parentheses and when we use square parentheses or brackets, okay? Now, most of us are clear with this. If you're not, an open dot would be used when I don't actually land on the value, okay? So it doesn't have an equal. So when I have this inequality sign, I'm putting in or writing and filling in open dot. Now for square brackets or square parentheses, I'm gonna use a closed dot. And it's when I have these inequality signs, which is a greater than or equal to or less than or equal to. That's simple. It's just remembering these. Okay, so here I have the domain of this function. Now, if I take a look at this function, okay, I wanna see at which x values. So domain is my x value. So I see a graph here. I see that I have a closed dot here. Okay. And an arrow pointing this way, and it goes to the left to infinity, negative infinity, right? It's going towards the negatives to negative infinity, okay? Now, I'd like, when we write it in set builder notation, I always say start from least to greatest. So from, just like we read from left to right. So when I'm reading a graph, I'm gonna start at negative infinity and work my way to the positive infinity, to the right. So if I were able to reach negative infinity way over there, which is impossible, we can't, it's a concept, okay? But let's just say, let's pick a value that's really down this line. Let's say negative 1 million. At negative 1 million, will you see this graph? Well, if I kept going, I would see that value of this graph at that point. So let me explain this way. If I'm coming in from the left, right, from the negatives on this graph goes infinitely that way. I'm gonna be coming on that graph, yes, I have a value. Yes, I have a value. Here, I'm gonna extend it a bit so that I can show you visually. So, a bit crooked, but we'll get the point here. Okay, I wrote it outside of the graph, so just so you have an idea that, hey, this is going all the way to negative infinity. Okay, so if I were to grab any point on this function and say, okay, what is my value of x? What is my value of x? What is my value of x? And so forth. See, I have values of x on this, or my domain for this function. And it continues in even fractions, right? Now it stops there and actually lands on that point because it's a closed dot. So if we were to count here what value that is, this is to the right, so there'd be positive 1, 2, 3, 4, and 5. So this would be positive 5 for my x. So therefore, in set builder notation, it's written negative infinity to a positive 5. Now, I can't actually land on negative infinity, like I've said plenty of times, right? So I don't put an equal sign. I'll write the x, then I write a less than, and an equal sign. The equal sign is because we have a closed dot. Okay, it ends there. So as I'm looking at this graph, this line, I'm saying, where do I stop seeing X values? So there's no more graph here. So I can't list off any more X values. I can't list off 6, 7, 8, 9, or 10 because there's no more graph there. Okay, so essentially when I'm trying to determine my domain, I'm looking at the graph and then going down to the x-axis, and listing those values. For the y, for the range, I would be going to the y-axis. Okay, now interval notation. We've been writing it in this form, which is set builder, recently in our class. But I want to show you interval notation. All we have to do is the same way, but instead of writing inequality signs, the parentheses and the bracket take its place. Okay, so we said infinity is included with the parentheses because we can't actually land on negative infinity. So it's going to be a parentheses always on a positive or negative infinity. We landed on 5. There's an actual value there, so I use the square bracket. And that's all there is to it. Remembering this here, that when it's a closed dot, I use square brackets, and parentheses on an open dot helps a lot.